On this tutorial, we're gonna make a tunnel 6 in 4 just to bypass an IPv4 technology zone and between some IPv6 stations. We have 4 networks and 3 routers. As we can see, the configuration of the networks of the 3 routers which are running on Ubuntu virtualized with VirtualBox over a MacOSX native system. First of all, we're gonna take a look of the configuration of the different interfaces on each machine. On router 1, we have the Ethernet 0 interface, which is IPv6 interface of this router. The ETH1 is IPv4, and we configured this interface. We can see it's Z0, it's automatically put for Ubuntu, and the tunnel 1 we coded it, as we can see right now, on the network interfaces file. We introduce the password, and we can see the 3 interfaces. The first one IPv6, the second one is the 6 in 4 tunnel. This address is the destination, the endpoint of the tunnel, and the first one was the starting point of the tunnel. And the last one, the Ethernet one, it's the IPv4 zone, and we had to add some root at net entries to the outside of the router that is on the middle of the 2 IPv6 zones. The third router configuration is exactly the same concept as the first router. Another tunnel in the other way to send transit from this one to the first one. And if we take a look at the interfaces file, we can see as well 3 interfaces: the tunnel, this is the endpoint. In this case, it's the middle router, and we also had to add some entries to the tables in order to address transit from router 3 to router 1. And now we're gonna take a look at the IPv4 router. We can see 2 interfaces, different networks, one to communicate via IPv4 with router 1, and the other one to communicate via IPv4 to the router 3. This is our IPv4 zone. If we take a look at the interfaces, we can see as we have configured 2 interfaces both on IPv4. Now we start Wireshark capturing both interfaces, and we start Wireshark capturing the IPv4 interface of the first router and the IPv4 interface of the third router. We're just going to test connectivity between the IPv4 zone. We send a ping to the router 3 from router 1. We can see normal packets, normal transit, IRP protocol, IMCP echoes of the ping reply and ping request. Everything went right. We have connectivity from router 1 to router 3 on the IPv4 interface. Now we're doing the same but from router 3 to router 1. And we can see we also have the IPv4 zone configured properly in both directions. Now we can see here the ping request and ping reply packets from the source router 3 with destination router 1. Now we close Wireshark and we are gonna test the connectivity of our tunnel. The idea of the tunnel is that it creates a virtual wire between the two nodes, the two hosts, router 1 and router 3, that both are dual stack, and it makes a virtual wire from one to the other in order to bypass the IPv4 zone. And how to test connectivity, we're gonna send a ping packet from one host to the other. I'm gonna see how IPv6 packet can be transmitted over an IPv4 protocol. Okay, router 2 needs to have port forwarding in order to retransmit the packets from R1 to R3 and R3 to R1. We just gonna test that we have one on the proxysnet IPv4 in this case, conf all forwarding. As we can see, we have one. If not, it won't be able to resend the packets. And now we're gonna do the ping 6 over the tunnel from router 1 to router 3. We capture the transit over Wireshark. Okay, everything went fine. Router 1 sent a ping request to router 3. We can see the ping request and ping reply, and here happens the magic. We can see here is that we are receiving IPv6 packets, and the tunnel are encapsulating those IPv6 packets on data of IPv4 packet. And here we can see, as we have protocol version 4, over that protocol version 4 encapsulated there is a IPv6 packet. And on the other side, we received the IPv6 packet that was encapsulation inside the data of the IPv4 packet. Now we're gonna test the tunnel on the other way. So we're copying the address of router 1, and we're gonna execute a ping from router 3 to router 1 over interface tunnel 1, which is our tunnel 6 in 4. And as we can see, it works both ways. We have received a ping request and we have sent a ping reply. In both cases, IPv6 packets. There's no IPv4 on router 1, and on router 2 there's IPv4 packets again, with which has inside the IPv6 packet sent from router 3 to router 1. Here we have the protocol version 4 and the protocol version 6 encapsulated inside it. And finally, on the other router, we have IPv6 packet only again. And this is the magic of tunneling traffic with the protocol 6 over the protocol 4.